Okay, so I've given you a few minutes on this, and we've tried some different u's, right? Have you hit a roadblock everywhere you've gone? Okay, so you use the numerator as the u, things aren't going to work out. Use the denominator, it's not going to work out. I heard some other options of what we could do. What was it? I heard quadratic formula, and then I heard, no, that doesn't, okay? But you're going down the right road, maybe, as far as what are my other options here? Factoring, so did you try to factor it? And what happens? It doesn't factor, right? So if I take this, huh? Oh, well, I'm sorry, hang on a second. I said it doesn't factor. It might factor, but let's look at it this way. Wait, did I even write this down right? Hang on a second. No. No, you're not slow. Hang on. So we can factor out a 2. So we can do that. I could say that this is the integral of, this is the integral, and I could take the 2 out, and that leaves me with 2x squared plus 4x plus 1, right? Over 2x plus 1, right? Now, if I take this and take the derivative of the numerator, it's not going to work. And taking the derivative of the denominator, it's not going to work. All right, can I factor the numerator? Even if I can factor it, will it factor into 2x plus 1 times something? Like this, I would have to get this factor in the numerator to be able to cancel it out, right? What did you get? Oh. Let's just check it. 2x times x is 2x squared. And then 2 times 1 is 3. And 2 times 1 is 3. Holy crap. Maybe that's what you did, because then it would work. 2 times 1 is 2 plus 1. That would be 3 there and not 4. That's the problem there. Okay. So it's okay. It's okay. All right. So we tried. That didn't work either, but we've tried a lot of things, right? I left off my dx, but I'm going to erase that anyway. All right. So there's another option. Besides just being able to cancel it out, do you also know how to, and it's okay, you don't have to erase everything. I did, so I didn't run out of room. You can just mark it out. Because you should be able to see that you tried some things and it didn't work. What's something else we did to reduce something like this? What is a fraction bar really telling me to do? Divide, right? And I can divide by canceling out. I also have long division. Oh, okay. Yes. So 2x plus 1 divided into 4x squared plus 8x plus 2. This long division looks horrific. It's really not that bad. It just looks nasty. And you got to make sure you do all the right steps. So I just look at the first term in each, and I take 4x squared and divide it by 2x. What am I left with? 2x. So I take 2x right here. Right? Then 2x times 2x is 4x squared. 2x times 1 is plus 2x. And then this is the step where people mess up. You cannot forget to change the signs. Then those cancel out. And you get 6x. And you bring down that 2. Yes? And then 6x divided by 2x gives me what? 6x over 2x would reduce to 3, okay? So then 3 times 2x gives me 6x plus 3. Then I cannot forget to change the signs. Then the 6x's cancel out, and I'm left with a negative 1. So I have a remainder, right? Okay, which is fine in this case. That's why we couldn't factor and make it knock out. So since it didn't factor, if I needed the x's, I would need to use the quadratic formula. Whoever said that, so yes, that would be helpful. We just don't need to do it for this question. So then what I have now is the integral of, and then since I divided this out, I took this divided by this. What I'm left with is 2x plus 3 plus, and then my remainder is negative 1 over 2x plus 1. And then that's a dx. Okay? So the two integrals I have there are equal to each other. It's just a different way to write it. It's a different form. We okay with that? So before I go and start deciding on u's and stuff, I have 3 terms there. Those first 2 terms, do I need a u at all? Or is that something different and simple? Different and simple, right? So I'm going to separate these integrals into the integral of 2x plus 3 dx plus the integral of negative 1 over 2x plus 1 dx. All right? So let's integrate this first side first. When I integrate this, integrate 2x, what is that going to give me? What do I do with this exponent? I get x squared, and then there was a 2 there, and then I have to divide by 2, right? So that's going to end up canceling out there. Plus, what does the 3 become? Three x. Okay, 3x. Yes? Okay. Now, am I going to need to use a u here? Yes. What would your u be? 2x plus 1. So if we let u equal 2x plus 1, then du equals 2 dx. Yes? Okay. Which means I need to multiply by 2 in here. So on the outside, I need to multiply by 1/2. But also, this is negative, and I need it to be a positive 2x, right? So basically, I can just bring that negative out front as well. Okay. So that means this is going to be plus negative 1/2 times the integral, and then my du is this 2 dx, and so I have 1 over u du. How do I integrate 1 over, so I'm just going to do this part for now. How do I integrate that 1 over u? What does it become? Yes, and when I integrate it, what does it become? Natural log. This is negative 1/2 times the natural log of u, absolute value of u. And then, of course, there's a plus c. I only need 1 plus c down there. So then when I bring all of this down together, all of this, then my answer is, those cancel out. I get x squared plus 3x minus 1/2 times the natural log, the absolute value of 2x plus 1 plus c. Okay, what questions you got? What would you... Okay, so there's lots of applications of integrals that we will get to. Okay, if that's why, like, why do we integrate it all? Is that what you're asking? Just in life in general? Well, we're about to get to a ton of application problems, and you will see. We've got, now, are you going to use this, like, in your literal everyday life at home? Probably not. Would you maybe use this in your career, depending on what you want to be? Absolutely. Yes. Yeah. Engineers and things like that. Yeah. So, yeah. Stay away from that stuff. But we'll look at lots of different, and there's lots of different types of engineering, you know. Do you know what never mind, I was going to ask you one that now I can't think of which type of engineering it is. Never mind, I'll ask you that another day. All right, any questions? Civil engineer, that's what I was thinking of. You know what a civil engineer does? It's like a city planning person, like they plan the roads, and, you know, those people, those are engineers as well. And you might need to know the speed of this and the speed of that and how many cars are going in and coming out, those sorts of things. We're going to have a lot of different types of problems where we apply this. I promise we'll get to the what is this even used for. We just got to learn how to do it first. Are we good? Okay.